Sir, please start the session.
Yeah, yeah, yeah. The second, one more important aspect in statistics and research, correlation and regression. Most of our classes we are using correlation and regressions. How are you going to differentiate these two things? So why you are going to use these two things, correlation and regression? Even though in the factor analysis you consider the correlations, in finance also you are using that is concept of correlation regressions. In share market also you are using. So it is very important things are correlations, multiple correlations, regression, multiple regressions, auto correlation, auto regressions. So ARMA is the auto regression moving average. Its applications are tremendous in actual field. In almost all every field, I'm not going to say that. So this field is exception for this one. But unfortunately, the things are happening, not happening properly. So 90% the things are applicable in share market at today's market. The predict, estimate. The first thing is that find out relationship between variables. In correlations, we are going to study the strength and direction of the variables. Okay. So autocorrelation comes. Autocorrelation means what? Whether you heard the name autocorrelation? In the share market is there. The trend, you are using the same concept in a different way. Trend. The trend is upward. Trend is a downward. The market is upward for 3 4 days. What yesterday happened? The same thing is repeated today. The same thing is repeated on next day. Autocorrelations. Regression. If variables are correlated, if you know the previous data, you can easily estimate future values. Predict. One is an independent variable, other one is a dependent variable. The equations are y is equal to a plus bx. Y is equal to a plus bx. X is an independent variable. A and b are constant. Y is a dependent variables. If you know that the constant a and b by using simultaneous equations. We can easily estimate the future value by knowing the independent variables. Here is I consider only one variables. If I am going to consider more than one variable, then it is called a multiple correlations, multiple regressions, multiple regressions. So x1, x2, x3, x4, x5 up to xn. The constant also same thing is slope. Just a 1 minute. Hello, hello. अरे जगदीश को भेज दो इधर कंप्यूटर का नीचे एक रैट है ओके नाउ multiple multiple regressions. In multiple regressions, two variables are the independent variables. The which variable is affecting on the dependent variables. Say for example, height and weight. हाँ सर ठीक है सर ओके सर हाँ ओके 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 सर हाँ ठीक है सर ओके सर थैंक यू So height and weight. Height and the weight is there. Uh, Otherwise, another example, height and weight. Okay, this is a single variable, height and weight. Suppose if add the one more variable, okay, one more variable like length of the shoulder, hand. If height is increases, weight is also increases. Just 1 minute. Take. Farooq? फर्क रख ले आपकी। अच्छा ठीक है, ठीक है, ठीक। So, what happens? Just about that. Suppose the two variables are there, x1 and x2. Okay. So in this case, what happens? Uh, Suppose the y is there. The y is considered as a weight. Okay, the person weight. So it is based on their height x1, arm length. I'm going to add one more variables, that is x2. See here, height and arm length are highly correlated. Height and arm length are highly correlated. That means the people with a taller height, they tend to have a longer arms. So here is what is the problem? To determine separately the effect of height and arm length on weight, because they are so closely related. So in this case, if the two independent variables are correlated, so it is very difficult to determine the dependent variables. First of all, you have to check it, multicollinearity. What is the meaning of multicollinearity? When two or more variables in a statistical model are highly correlated with each other, the making it difficult to determine the individual effect of each variable on the outcome. So these consequences of multicollinearities result in the form of inflated variance of coefficient, that I am going to show you by taking one example. So here is the first of all, I want to take simple linear regression. In this simple linear regressions, y variable based on variable x is there. So that means suppose I want to predict the house price. I want to predict house price. Say for example is a y. So the house price is predicting based on what? Size of house. That is x. Okay. That means every additional square root, sorry, every additional square foot value of x increase the value of the house. That is y. Okay, by certain amount. So these equations you are going to use it, y is equal to b naught plus beta naught plus beta 1 plus error factor. Here y is considered as house price, x is considered as the size, beta naught intercept part, beta 1 slope price, The price increases per square feet. I hope I will tell you equations. Just 1 minute. Just I want to open that file. My screen is visible for you.
Yes, sir, visible.
Yes, sir.
See that. This is what equations I quoted. अरे फोन करो सोराम सर को कांटेक्ट करने के लिए बोलिए सोराम से सर. So here is equation beta naught plus beta 1 x plus residuals. Okay. So this is the equations. We have to find out the value of beta naught and beta 1 and x values. You are going to estimate the value of y. Okay. So what are the applications of this? The applications of that one is a predicting energy consumption. It is based on what? Building size and energy consumptions. Stock market analysis predict stock prices based on company performance. Based on company performance. In medical research, predict patient outcomes based on treatment dose. One is a dependent, other is a independent. Quality control. So the product quality based on manufacturing process. Manufacturing process. So these are the applications of linear regression models. If you are taking two variables at a time, two variables, that means it is considered as what? Multiple regressions. In the multiple regressions, things are different. How the equations are there? Just 1 minute. Yeah. So in multiple regressions, y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus residual. So here is the three variables are added. One is x1, x2, x3. So x1 is the size of the plot. Then x2 is another variable, number of bedrooms we consider, and x3 is the location. So on the basis of three variables, we are going to estimate the price of the house. So here is interpretation of this value is beta naught is what? Initial price. Then beta 1 is change in price per one unit, change in size. Similarly, beta 2 change in price for one unit, change in the number of bedrooms, x2 variables. Similarly for beta 3. In beta 3, change in the price of one unit, change in the location, x3. Error factor is there. Okay. So these are the mathematical equations of regressions. But manually it will take more times. But we are using the software. The simplification is very, very easy. So we have to analyze the things. In this context, the two things are important. The one is comes multicollinearity. We have to check it by using the variance in inflated factors VIF. I will show that. Linearity, non-linear, homoscedasticity, the heteroscedasticity. So these terms are we are using in these regressions. Linearity means you know that the relation between the two variables should be in the straight but not curved. Okay. Non-linear, not a constant. See, suppose in the non-linearities, for example, you are using the water to the plant. One plant needed 1 liter water. Two plant 2 liters. Okay. 3, 4 liters or 5 liters. So there is no any fixed increases. Randomly one can increase. So one more term is comes homoscedasticity. That means the spread of the data points should be consistent across all level of the predictor variables. That means what? Simple examples I want to say that here consistency. The predict the how much money the people spend on food based on their income. Means the money spending on food is consistent across all income levels. Suppose if your earning is 1000, same amount you're spending on food. If your income is 50,000 rupees, the same amount you are spending on food. So there is no any changes. The spending money on food when income is varied. So these kind of variables are considered as the homoschedasticity. The one more terminology comes heteroskedasticity. That means here is no fix at all. The spending money on food either it increases or decreases with income level. If income is more, the spending on food is more. Income is less, the spending money on food is less. So if the things are happening in the variables, that those things are considered as a hetero, otherwise homo. So these are the important things. And in a linear regressions, output analysis also there. So whenever regression point is comes output analysis, the first part is a descriptive, the second part is a correlation is comes, third part is comes regressions, okay. Fourth point is analysis of variance, okay. We will get it all type of tables in our problems. We take one examples how to solve it. Any doubt in your mind regarding the regression and correlations, linear regression and multiple? See that this is a problem. The height and weight is there. Okay, simple example. So analyze, go for correlate, bivariate. The variables are height, weight. Now take the Pearson. Okay, options are there. I don't know. Okay, no problem. Transfer. Not necessary. See that. Correlation height and weight. So height and weight correlation is negative minus 0.700. Negative correlation is there. Okay. What is meaning of a negative correlations? One variable is increases, other variable is decreases. What is a correlation? Correlation is a significant. Direction is what? Negative. What is the strength? Negative correlations. One variable is increases, other variable is a decreases. Okay. Now, now So I want to take one example on linear one minute. The same example I can do it. Regression linear. So to take anything, height is a dependent variable. Okay, the weight is independent. You see that statistic here is mm, collinearity diagnosis here is there. Okay, this you have to check it. See that polarity statistic is a VIF, the variance in related factors. If it is one or more than one, polarity is there. This is a factor to calculate collinearity of statistics. It depends on the problem. It may be the suppose the more than 5 or 6. There is no collinearity in that one. The two variables are independent. It is very difficult to estimate the dependent variables from that. Measure means what? Which factor is affecting on the dependent variables? So that you can't understand it. That I am going to take one example. The for example is a BP is there, pressure, age and weight. The BP is varied the because of the age or because of the weight. First of all, you have to check about the linearities, collinearities. Thereafter, you can go for that. Okay. So I'm going to take one example. I'll take one example. Sir. I want to create it. See that. So I'm taking simple example. Directly I can take it. One is the income. Okay. Numerical. Decimal point is 0. This is a scale. Okay. And expenditure. Income is something I'm taking the small number. Okay. Expenditure 72, 66, 85, 95, 108, 112, 118, 138, 130, 152. Okay. So this is the problems. The first of all you have to define null hypothesis. Null hypothesis is that what is the effect of x on y. So it is based on beta value. Beta means what here? Beta is a coefficient value, slope coefficient. Okay. The beta is there. So I'm taking the single one. So beta naught into b1 into x. X. The two variables. Only one variable is there. One is a dependent variable, and second is a independent variable. Just 1 minute. 1 minute.
सेक्रेटरी हमारे डिपार्टमेंट में पूजा है तो आना है सब सबको ऑल स्टॉप 12:30 ठीक है
Thank you.
थैंक यू
Thank you. So here is one is a dependent variable and second one is a independent variables. So that is intercept is my null hypothesis is beta not equal to 0. That means no significant effect of x on y. X on y. X is independent, the y is dependent. This is my. So these problems I want to solve by regression equations. Analyze regression linear. Okay. So what is our dependent variable? Expenditure. Income is independent. go for statistics, vulnerabilities, check it, confidence interval is not required, continue, selection variable. See the result of that. The first thing comes the model summary, R, R square, ANOVA table, regression and residue, and coefficient values. Here also I am using the eigenvalues in more than one. Dependent variables are expenditure. Okay. Here is coefficient values. VIF is 1. So polarity is there. Now R square is there. R square is 0.879. So what does it indicate? So the shows the variations 87% variation in dependent variable due to independent variable. That means the variations of expenditure explained by income. So 87%. This is ANOVA table shows that the significant values less than 0.05. That means our hypothesis reject. Hypothesis is reject. That means this model does not fit the data better than intercept only model. That means model is statistically significant. See, slope values that is slope. Coefficient values. This is the income coefficient values 0.87. 0.87. That means if income changes 1 unit, expenditure changes by 0.48. So this methodology changes in the expenditure. This is the so in analysis of regressions, you have to consider R square values, then slope is there. So that 0.87 is there. See, look here. This is the income and expenditure. Okay. Suppose income is 300, what would be the expenditure? What would be the expenditure? Anyone? On the right side, 100, 300 plus 26. So 172 is comes. This value is comes approximately 172. Is it clear? Is it clear? So for understanding purpose, I am taking the simple examples. You can estimate it. Finding the constant values. Okay. Do you want to take one more example on this part? Yes. Do you want one more examples on this? This is clear? Audible or not audible?
Yes, sir.
Yes,
Understood.
audible.
Yes, sir, audible.
आया सर समझ में.
Okay. Now I take one more example. Multivariate. Not multivariate. Multiple regression. In this multiple regressions, so I am taking this example. Here is the participant values are there. Set nothing, but it doesn't carry any meaning to this one. So this will be it. It is a GRE course, quantity score is there. And the second is the GPA, that is cumulative. And next one is comes, that is a grade is that. Quantitative score, cumulative, GPA, and grade. Okay. So GPA one can use to predict the performance in that course. Okay. Taking only the 30 numbers. So I am applying regression analysis. Analyze. So these are the three variables. Sorry. Okay. So dependent variable is a grade. Independent variables are GRE score and the GPA. Yes. So statistics, estimate, model fit or not, and polarities. Okay. So you have to take into consideration of all these things. Okay. Yes. Just one minute. Mistake somewhere. So this also not really important. This plot is there. Okay, you can understand that better. Histogram normal probability plot. Very good. See that. Model summaries comes. R square. So predictor constant GP and grade. Dependent variable is a grade. Yes. NO 0.004. Coefficient values. The polarity is 1.07, 1.07 is above the 1 is there. Okay. The constant is a 77, beta 1 and beta 2 values. Okay. Beta 2. Mm. See that. I'm using the plot normal distribution of people. So scatter plot, the diagonal points are falling above the center line. Here are close. So this is a scattered. Non-normal is expected probability. Non-normal variables. So variable. Mm. So the R square value comes to 0.342. So that means 34% is there. Variations in dependent variables due to the independent variables. 34% is there. So here is our dependent variable is grade is there. Okay. So 34% variations of, yes, the grade explained by the GP and GRE score. So here is suppose GRA score is then GPA is 3. What would be the grade? Are you able to estimate this one? This is our equation. What is your equation of the equation is y naught is equal to b naught plus beta, sorry, beta naught plus beta 1 x1 plus beta 2 x2. Two variables are there. We can remove this one. Okay? Yes? Only two variables are restricted. So by using these equations, we can easily estimate the value of the dependent variables. Here, beta naught, beta 1 and beta 2 values are getting from the table values. See that this is the constant is that 77 and this is beta 1 is the 0.03 and this is a 0.05. So if you substitute the values in that one, you will get it. See, that is, you take round figure. So the values of there is a 400 and this is a 3. So it comes 90.96. The 420 is 91 is there. This is 400. The summer 460. GPA is more. Therefore, values comes less. This is a contradiction of 90 and this. Okay. But here 420 is there. We consider GPA is the 3. Yes, on that basis it becomes 90. If we consider the GPA is changes, the grade is also changes. Okay. And this is a linearity, one can check it. Yes. So here is also there how to check it. Descriptive. Explore. Just analyze and describe. Now, here is the charts are there for testing the normalities. The PP plot is there, PP plot is there. If you select this, either this or that, these are the variables are there. Okay. This normal. Okay. See that how the points are falling near to the diagonal. So that is indicating what normality is. This is the score, GRP. Deviation from the normal, D trend. GPA, expected normal value is like this. D trend normal. If it's like that, the points are coming like this. So this is our reference table. If normality tested, your graph is comes like this. All the points are falling near to this. Great. The observed values and expected values. So it is available over here. Okay. If you enter this. The somewhere it is there. Frequency is also there. Normality test is there. Variance and mean median. So okay. In this way, you have to check the normality for testing and all these things. And for multiple regressions, the first table is comes the model summary is there. In the model summaries, you take into consideration of that R square values. How the values are changes in dependent variable. What percentage? अगर independent variable 1 unit change हो गया तो dependent variable में तो कितना percentage? That you can check it from R square. So MO table shows whether model is a fit or not. But sometimes models are not fit. It is a significant. Okay. All these things based on the problems you have to interpret it. The most coefficient value, this is important, is the PI, the variations inflated factor. It must be more than 1. If less than 1 is the multipolarity is there. The 1.007 it is acceptable. So from the coefficient we can get the values over here. From this one you can estimate the anything. So all these things are related to multiple regressions. So many things are there. Do you want to take one more example on that?
Yes, sir.
To take one example of the BP and age and weight. To take new example. Okay. Data view, variable view. Data, I'm taking that data is that blood pressure. Okay. This is a scale is there. Then you can take it age, decimal point. This is weight. To enter the values, BP 105, 120, 107, 109, 119. Okay, taking few numbers. Age 43, sorry, 43, 38, 47, 42, 48, 39, 37, 41. Weight is there. 71, 82, 73, 83, 77, 81, 79, 80. So in this case, what is our dependent variable? Anybody? Dependent variable. This is a dependent variable. Agree? So age is independent variable. Independent variable. Dependent variable. Weight is also independent variable. Okay. Now this is a dependent variable, age and weight. So which factor is affecting on BP?
Weight as well as weight.
If these two are correlated, so it is, suppose only one variable is the age. If the age is more, BP level is, BP is a variation is there. Along with the weight is also increases. To consider this, age is 43, BP is weight is a 75. Okay, but here is age is more, weight is less. BP is 120. Here age is a less, weight is 81. BP is 112. Suppose if the weight is a 40, the BP is 70, what would be the BP level? This is it, approximately. There are so many factors are there. BP. Take into consideration of the previous value of the ages and the previous values of the weight. What would be the BP level of age is a 40 and 70. First of all, we must check about polarity. How to check it? Go to analyze, regression, dependent variable is, so again, I want to remove this. Analyze, regression, linear. Okay, dependent variable is BP, age, dependent, weight, dependent. Now go to statistics. Can check it whether model is a fit or not and estimate. Thereafter, polarity diagnosis. Descriptive and take. Okay. You can go for a plot. X-axis and y-axis. Histogram and normal probability. X-axis, what you are going to take it? Necessary. See that. I told it output. The first step is comes descriptive. Okay. The descriptive, the mean and standard deviation. Okay. Mean is like this. Standard deviation is like this. Observations are 8. Okay. It is just information. In second part is comes correlation matrix. In the correlations, BP and age negative correlation, BP and weight negative correlation. The Pearson correlation coefficient, because it's a symmetrical matrix is the whatever values are here is coming over here. See that. Okay. Age and BP. This number is comes. This is a diagonal line is there. One. So here is both are negative correlations. Next part is comes regression output. This is a regression output is there. So R square value is there 0.80. Okay, 0.88 square. R square is 8. 8% is there. Change is very less. Degree of freedom dependent variable this. Okay. Model is not fit. 0.813 is greater, but it is greater than 0.05. Okay, here is also comes polarity is 1.235. Okay, it's a little bit high. And the things are not. Suppose suppose I increased instead of 8. Model is not fit. 0.965 is the risk. And R square value is also 1%. Polarity is there 1.033 less. Eigen values also these two are not. Okay, I use only one more than one. Okay, data is not supporting our result. Yes, because random numbers you consider. Okay, these are random numbers are there. So that is why showing that one. Negativity is there, correlation. See that. B and H is a negative correlation. Minus 0.115. Low correlation. And weight is also that is minus 0.178. This is same thing as that. Okay. Any questions regarding this matter? So all these things require the practice is important. Is that when you take the some this one you read the journals, standard journals, and go through the analysis work. Okay. So interpretation is also most important. Is that all these things that are based on your objectives? According to that, one can define in proper ways. Okay. So first thing is that understand the little bit statistic, the concept. Thereafter, use SPSS. This one of the best tool is there for analysis, statistical analysis. So many things are there. Okay. Some scholars are using Excel is there. Excel not that much of powerful like SPSS. Okay. So any questions, any discussion?
Scholars. Any questions? Please ask to sir. Today is the last session on SPSS.
Thank you so much, sir.
If any problems are there, you can contact to my number is there. Okay. For any analysis
नंतर
work
करते.
or data collection. This is my
Yes, sir. If possible, can you share your number in chat box, sir?
okay, okay. Just 1 minute.
एक मिनिट बोलू का मॅडम?
हा बोला ना.
विद्यार्थ्यांनी लक्षात ठेवा, तुम्हाला सबमिशन वगैरे काय करायचंय काय नाही त्याचे फॉर्मॅट्स वगैरे सगळे मॅडमनी ऑलरेडी ग्रुपवर दिलेले आहेत. आज पण तुम्ही तेच विचारताय म्हटल्यानंतर अवघड आहे. तुम्ही ग्रुप सुद्धा बघितला नाही. आज मला भरपूर फोन आलेत, सर्वजण तेच विचारताय की हे काय करायचं ते काय करायचं. आता
सर एक
सबमिशन 2 दिवस.
दोन मिनिटं सरांना हे करू दे, मग बोलू आपण.
बरोबर, ठीक आहे.
हा. कोणाला डाऊट्स आहेत का? प्लीज आस्क क्वेश्चन्स अबाउट रिलेटेड टू SPSS ओनली. I think no one has doubt. Dr. Biradar sir, I am very much thankful to you. You are taking 6 days on SPSS. It is a detailed uh, teaching and learning to us. So I am very much thankful on behalf of Professor Ramakrishna More College, Department of Commerce. Very much thankful. You already circulated your number in our chat box. So
Yeah.
if any query, our scholars will ask to you. Thank you very much, sir. Thank you again.
Okay. Thank you very much.